Explain the video goal and say this will cover what telecommunication systems are, their main parts, how signals move from sender to receiver, differences between wired and wireless systems, common network architectures, basic protocols, and high-level issues such as latency, capacity, reliability, and security. Give a simple definition of telecommunication as the exchange of information over distance using electrical or electromagnetic signals for voice, data, and multimedia services. Describe the basic end-to-end concept in plain terms. A sender encodes information into a signal, a transmitter sends the signal into a channel, the channel carries the signal possibly through repeaters or routers, and a receiver decodes the signal back into usable information. Introduce the core physical components without technical build detail. Transmitters and receivers, antennas and cables, base stations and routers, switches and gateways, multiplexers and demultiplexers, repeaters and amplifiers, and the core network elements in data centers that route and manage traffic. Explain analog versus digital signaling simply. Analog represents information continuously, while digital represents information as discrete bits. Modern networks primarily use digital signals because they are easier to compress, correct for errors, and route efficiently. Describe common modulation and multiplexing ideas at a high level. Modulation changes a carrier signal to carry information. Multiplexing allows multiple signals to share the same channel by separating them in time, frequency, or code. These techniques increase capacity and efficiency. Explain how wired systems like copper and fiber carry signals. Copper uses electrical waveforms and has higher attenuation and electromagnetic interference. Fiber uses light and glass and offers much higher bandwidth, lower loss, and longer distances between repeaters. Describe wireless systems conceptually. Radio waves carry signals through the air. Cellular networks use cells and base stations to cover areas and hand off mobile users between cells. Wi-Fi covers short ranges with access points. Satellites provide wide area or remote coverage and introduce higher latency. Cover network architecture and layering in plain terms. Access networks connect end devices. The transport and core networks move traffic between points. Protocol stacks break tasks into layers such as physical transmission, link reliability, network routing, transport reliability, and application services so systems interoperate. Explain packet switching versus circuit switching simply. Packet switching breaks data into packets that travel independently and are reassembled, enabling efficient use of networks. Circuit switching reserves a dedicated path for the duration of a session and is less common for data but still used in some legacy voice systems. Discuss addressing, routing, and the role of Internet protocols at a high level. Devices have addresses and routers forward packets toward their destination using routing tables. IP handles addressing and routing while transport protocols like TCP and UDP manage reliable delivery or low latency delivery respectively. Mention quality of service and performance factors in plain terms. Bandwidth is capacity, latency is delay, jitter is variation in delay, and packet loss reduces quality for real-time audio and video. Networks use prioritization, buffering, and error correction to meet application needs. Talk about security and privacy conceptually. Encryption protects data in transit, authentication verifies users and devices, and network operators use firewalls and monitoring to detect attacks. Spectrum management and lawful interception are regulated activities and must follow laws and standards. Describe how mobile cellular networks are organized without implementation detail. Radio access networks connect phones to base stations. The core network handles mobility, authentication, billing, and interconnection with other networks. Generations like 4G and 5G reflect advancements in speed, latency, and capacity driven by standards bodies. Explain operational and maintenance concepts at a high level. Operators monitor networks for faults and performance, run capacity planning, deploy redundancy to avoid single points of failure, and perform upgrades and security patches in scheduled windows. Suggest safe learning paths and resources. Study textbooks on communications and networking. Take online courses on digital communications and networking protocols. Read standards from bodies such as E2, IEEE, and 3GPP for high-level context, and explore vendor white papers and accredited training programs. Summarize the key ideas. Telecommunication systems move information from place to place by encoding signals, transmitting them over wired or wireless channels, routing them through network elements, and decoding them at the destination. Design balances capacity, latency, reliability, cost, and regulation. Visual suggestions for the video input. Show animated end-to-end flow from sender to receiver with signal encoding and decoding. Show simple diagrams of packet flow and protocol layers. Show images of fiber optic cable, cell towers, satellites, routers, and data centers. Show overlays explaining bandwidth, latency, and packet loss. End with a call to action to learn networking fundamentals through courses and professional sources.